Hi everyone, today we're going to be talking about linear systems. We're going to be solving linear systems by graphing and by using the substitution method. Go ahead, grab a piece of paper and a pencil, and let's get started. Okay, so the first example we're going to look at, we have one equation that's already rearranged into y equals mx plus b form, and that's y equals 5x subtract 2. And the second equation, 6x plus 3y equals 15, will need to be rearranged into y equals mx plus b form so that we can graph it. So let's first go ahead and graph line 1. I like to start by labeling my lines with 1 and 2, and we're going to start with number 1. So first we need to identify the slope and the y-intercept. So we're going to plot the y-intercept first. So the y-intercept, or the b, is at -2. So I'm going to go ahead and put a dot at -2. And from there, I'm going to rise 5, run 1. And then I'm going to rise 5, run 1. And then I can connect my dots. Okay, we should draw arrowheads at the end of our line for good communication. And label our line. You can either label it with a 1 or y equals 5x subtract 2. Okay, the second equation we need to rearrange. So I'm going to subtract 6x from both sides. Okay, next we need to divide all terms by 3. So here, y equals -2x plus 5. Okay, now we can go ahead and plot this new line. So again, we're going to start with the y-intercept, so we're going to put a dot at +5. And from that dot, we're going to go down 2 to the right 1. And then we can go ahead and connect our dots. And again, for good communication, go ahead and add arrowheads to either end of the line and label your line. Okay, so we can see that the point of intersection is at 1, 3. So I'm going to make a conclusion. So therefore, the POI, or the point of intersection, we can also call it the solution, is 1, 3. Okay, let's look at our next example. The next example we are not graphing. We're going to solve by using the substitution method. So again, I'm going to start by labeling my lines 1 and 2. And right now they're both arranged in y equals mx plus b form. So what I can do, since they're both y equals and y equals, is I can actually substitute, which is why it's called substitution, or replace one of the y's with the x plus 3. Or 2x plus 5. So I'm going to put the x plus 3 from equation 1 into equation 2. So I like to write sub 1 into 2 for good communication. So x plus 3 equals 2x plus 5. And then I can rearrange and subtract x from both sides and subtract 5 from both sides. So essentially what I'm doing is I'm moving all of my x's to the right, all of my constants to the left. So then I can simplify. So on the left I have -2, and on the right we have x. So x equals -2. Well, we're halfway there. We have the x part of the solution. Now we need to figure out the y part of the solution. So what we could do is we can take that x equals -2 and substitute it into either equation 1 or 2. I'm going to substitute it into equation 1. It looks a little bit easier to work with. Okay, so then we have y equals -2 plus 3. And simplifying, y is equal to 1. And then the last thing we need to do is put it all together to make our coordinate. So therefore the solution would be -2, 1. Okay, let's look at our next example. Okay, so let's again start with labeling equation 1 and equation 2. So I have y equals -2x plus 3. I'm going to call that 1. And y equals 5x minus 4 is going to be equation number 2. So again, they're both rearranged into y equals mx plus b form. So I'm going to take the -2x plus 3 and I'm going to substitute it into equation number 2. Okay, so I'm going to write this as -2x plus 3 equals 5x minus 4. Okay, so I'm going to rearrange the equation so that my x's are on the left and my constants are on the right. You could rearrange it the other way. It really doesn't matter. I just want my x's to be positive. So I'm going to write 3 plus 4 on the left equals 5x plus 2x on the right. Then simplifying, I have 7 equals 7x. And solving for x, I divide both sides by 7. So x is equal to 1. So again, we're halfway done. Now we need to find the y value. So I'm going to take that x equals 1 and I'm going to sub it into either equation 1 or 2. It doesn't matter. I'm going to choose equation 2 because the x is positive. So y equals 5 times 1 minus 4. So simplifying, y is equal to 5 minus 4. So y is equal to 1. So then I can conclude that the solution to the linear system is 1, 1. And I often abbreviate solution SOLN for solution. Okay, so this is the last example. This one's a little bit different because the second equation is not in y equals mx plus b. However, the first equation is in y equals mx plus b form. So I'm going to approach it very similar to the previous two questions that we looked at. So I'm going to start by labeling 1 and 2. And then I'm going to take my equation 1 that's in y equals, and I'm going to replace the y from the second equation with 5x subtract 2. So I'm going to sub 1 into 2. So I'm going to rewrite this as 6x plus 3 times 5x subtract 2 equals 15. Okay, so now I can simplify. So I'm going to write 6x plus, and I'm going to distribute the 3 through to both terms inside the brackets there. So 6x plus 15x minus 6 equals 15. And then I'm going to add 6 to both sides. So then we have 21x is equal to 21. And then solving for x, x is equal to 1. So again, we're halfway there. So I'm going to take my x equals 1 and I'm going to substitute it into either equation 1 or 2 to get the y. And looking at the two equations that we have, I think it would be easier to substitute into equation number 1 because it's already in y equals form. Okay, so sub x equals 1 into 1. So y equals 5 times 1, subtract 2. So y equals 5 minus 2, y equals 3. So I can conclude that the solution to the linear system is 1, 3. Okay, again, the solution is 1, 3. That's it for today. Thanks. Have a great day. Bye-bye.